Alright guys, I got a big package from Canada with a lot of frames. These are, for example, the Cool 35 frames, and Toronto FPV also sent me his 4-inch frame, which is called the Ballerina, and he basically challenged me to build it in under 6 hours, and I'm pretty sure we can do that. So let's get started. I already put in the stack screws. It's a single plate, and one important thing is to slip in the LiPo strip before you put in the AiO. So I think we start by tinning the AiO. I'm using the Gapper C Taker G4 35 amp. So first we put on some flux, and I think I will start with the battery lead. I'm just tinning all the pads for the motors. I think we can do the U-outs as well. Okay. Always close the bottle, because then we don't have any accidents. So let's see if there's an indication which is which. Goes on like this. I like to, it's pre-tinned from the factory, but I like to cut that part off because the factory tinning is with some weird solder that doesn't like to solder very well. When removing the insulation, I try to remove about as much as the pad is long. So that's done. Let's start with tinning the AiO now. Putting a little bit of solder on the tip helps with spreading the heat to the pad, and then you just heat up the pad and put the solder on like this. I got the soldering iron at 420 degrees. That helps with getting it done quickly. And I'm using a little bit of a bigger tip because it keeps the heat better. That one. Okay. Always keep the tip clean. And I'm moving the AiO because I don't want to go over the board with the iron. That helps with not accidentally putting solder where I don't want it. As you can see, I'm coming from here with my iron, and that way I don't move over the board unnecessarily. And I'm cleaning it a little bit further away, because when there is no chance of accidentally spraying solder on the board. I'm doing the UART pads later because I got the bigger tip on and I might need the smaller one for it. Okay, another important thing is to pre-tin your cables, especially the bigger ones. For that we put a little bit of flux on the cable, because then the solder will creep in better. Like this. Close up the bottle. Then we can go to tinning the cables. Putting a little bit of solder on the tip. This can take a little bit more. If you still see strands, it was not enough. Ah, that looks good. And you want to go fairly fast here too, because the solder will creep up, and as you can see, there's like this stiff part where the solder is, and that, if you are going too slow, it will creep further into the cable and the cable will become not as flexible. So now we make sure not to solder the wire wrong, because I already put on the capacitor. So it would be bad if we solder it to the wrong pad. Using the tweezers for this, because I don't want to burn my fingers. Go like this. A little bit of flux. Clean tip. A little bit of solder on the tip to spread the heat. And we start with the hardest one, which is the black. Go like this. That took too long. A clean tip helps a lot, so make sure to clean it often. There you go. If this takes too long, you might need to turn up the heat on the soldering iron. And that looks pretty good. So this is how it should look like if you're doing it right. Okay, so now the next step will be to put the AiO into the frame, put the motors on and solder the motors, I would say. We go like this. Maybe like this. We can do shorter yard cables. I printed some spacers. Those are available on MakerWorld. And those give me a little bit of space under the AiO for the LiPo strap. So if I have to change it out, I got more space to do that. Okay. Let's put on the motors. I like to put the motors on before cutting the cables because that way I'm sure that the cables are not too short after cutting. So let's do that. I feel like the screwing part is what takes longest when building a drone. Also it helps a lot if you prepare your stuff. It might look chaotic here, but I have my screws already selected that I'm going to use. And I checked if they are long enough or short enough. So I now just have to grab the motor, put it on and put the screw in. Also it helps that the frame comes with only 2 motor screw holes, so you don't have to put 4. Technically you don't ever have to put 4, but yeah, if there are 4 screw holes you might want to use them. I think you can turn down the iron for a bit. So this one I had to... and that one was on a discus before, so the cables were too short. And I already extended those. But I might have to do it again because maybe it's like... yeah, you will see. Hopefully not, but we might have to do that again. That will cost a little bit of time. But 6 hours should be doable. The last motor, I'm using the T-motor F1404 with the 3800 kV. It might be a little high kV for 4-inch, but I also got some bi-blades, so I think we will be fine. It should be fairly efficient. I think the motors are pretty efficient actually, which is why I'm using them. Let's double check the screws. I don't want to do those again. Looks good. Looks good. It's good. Alright. So now we move the cables. This goes like this. Yeah, that might be a problem. I have to do this one again. Probably cut it here and do the extension in the middle of the arm. Let's do that right now. Like this, and then we extend it in a way that we don't have the extension right at the solder joint. Okay, but the other motors should be fine. So we do those first and then we do the extension later. I like to put a little piece of tape here instead of a zip tie, because I don't like the zip tie cutting the insulation on the cables. So we go like this, and then wrap the cable with the arm. Nice and tight. So nice. I just wind it around the arm so that it doesn't get in the way. Nice. That is looking good. I think we cut the cables now, because I don't like them flopping around. I give it a little bit of slack, so we don't have any issues later. So go like this. That's the one we have to extend. Oh, come on. Be safe was, because we might need them to extend the cable. Okay. So the plan with the build is to have it efficient and be able to carry the DJI Nano. So I'm planning to use this for filming only, not for freestyle. Honestly, it's not meant for freestyle anyway. Not that it can't do it, but yeah. Okay, let's tin the cables. I think this is a fingernail angle here. You can use the pliers to remove the insulation, but you have to be very careful with the smaller cables, because if you cut the strands, the cable will be weaker and it can be a problem, obviously. And also I'm not removing too much insulation. Just about as much as the pad is big, because if you remove too much, then the cables might be able to touch and short out, which is a bad thing, obviously. Turning on the soldering iron so it can heat up. Okay, we can do these as well. For extending the cable, I'm removing a little bit more so we get a bit of space. Like this. That looks good. And we are using some of the cable we cut off earlier to extend this motor. I think it should be fine if we do like 5 millimeters. Twisting it a little bit. Okay. Just making sure that there are no strands sticking out in a direction I don't want them, because that might short the cables, because the pads are fairly close together. Okay, we put some flux and then we can start soldering again. Usually I would use a little fan to blow the flux steam away, but since I'm using the camera, I don't want you to hear the fan blowing all the time. So we put a little bit of flux on the cable ends to tin them. Doesn't need too much because there's also a flux core inside the solder I'm using. And for the smaller cables that is most likely already enough. Put some of it on those as well. Okay. Closing the bottle again, because we don't want the accident to happen. Okay. So let's tin those first. Tip looks clean. Move the board away so we don't spray anything. That looks good. So now do the cables on the motors. Let's clean the tip. Nice. I think we do the cables now. Let's see if the solder is, or the flux is enough already. It's looking good. Oh, no. Yeah, we need a little bit more flux here. So you can see it didn't want to stick together. So I think we put some here and some here. Let's just put it on the arm for this. Yes. Okay. That's the solder here. Okay. You see, I'm cleaning often. Because it just helps a lot with soldering. But it's looking good. Now we put some shrink tube on it. It's not good. Oh, that should work. A bit longer than the solder joint. Okay. Nice. Let's just do those together. Yeah, it's not looking perfect, but we don't see it again, I think. Okay, so that's done. Now we can fix the cable to the arm and cut it to length. And then we can finish the motor soldering. And get to the actually complicated stuff, the smaller joints. Okay, this is looking good. Now we don't have the extensions too close to the solder pads. Cut the cables to length. Remove the insulation for soldering. Like this. We put a little bit of flux and then we start tinning. Okay, that is nice. Close the bottle. We are at 33 minutes. So I think we are on a good pace to finish the challenge in under 6 hours. Okay, tip is clean. A little bit of solder on the tip. And now we tin the cables, still not moving the soldering iron over the board. Cleaning. Doesn't need too much because the pads are tinned as well. It just helps with the heat transfer if you tin the motor cables. Like that's a common mistake beginners do, not tinning the cables. it just helps with soldering. It's mandatory, I would say, to do this. Cleaning. Okay, so now we can go and solder the cables to the board. We'll use a little bit of flux again. Put it on the heads here, like this. Not too much, so we don't have to clean it afterwards. Clean tip. Little bit of solder to spread the heat faster. Now start soldering the motors. Maybe I shouldn't have put the standoffs before that. It's a little bit much. Nice. Always keep cleaning and move your board around so you don't have to move the iron over the board. Oh, we went into sleep mode. I was wondering why the iron was too cold. Because I have a pretty good one. That shouldn't happen, but if you have it on too long, it goes into like a standby mode and goes down to 180 degrees, which is obviously too low for soldering. And now we are going nice. As you can see, with enough heat, this goes fairly smoothly. So if you are struggling with this, it's most likely a heat problem or a heat transfer problem. So putting a little bit of tin on the iron helps with that. Oh, this is not right on the pad. It looks good. I don't like that the quad is moving, so I just put it on a clamp. I think you can just grab. Nah, it's not enough to grab the motor. We just do it on a standoff like this. Okay, now that should be stop moving a little bit. There. Okay. And we move again for the last pets. Because as I said, I don't want to move the iron over the board. Like usually it shouldn't trip, but you never know, right? So better be safe. Nice. And the last one. So that was the motors. Now have a look at it. This is how it's looking now. I will move the cables so that they are nice and neat, like this. And that is already looking pretty good. So I have the wiring diagram here. Let's see where we put the VTX. I think I will use these keywords here. So that would be these ones. Maybe we do this one for the. I'm putting the receiver here on R2 and the VTX will go to R4, I think. Oh, this is the VTX I'm using. It was in a build before, as you can see, it's already coded. I'm not coding this quad, but who cares? And I actually got a new receiver for it. So I think the next step is preparing the receiver. That's a Radio Master RP1. Where's the pads? We just fix it in place here. And do we switch out the... Yeah, I think we switch the tip for this. iron is still hot, so we use some pliers to take the tip off. Put the new one in. The smaller one, by the way. And we are losing power again. Okay, well, it looks pretty clean actually. And while we wait for the iron to heat back up, I'm pretinning the pads. Like this. Closing the bottle. Okay. What are the cables? Okay, let's go. There's my solder here. That is looking good. Neat. Okay. The camera is not behaving. We might have to do a little break. Okay, let's just be nice and tin those as well. Because why not? Alright. Come here. Those little cables. That's it. For those little solder joints, you basically just touch it really quick, and that's already it. So I like to move the antenna like this, so that it comes out at the same side as the cables. And then the receiver comes with those little pieces of shrink tube that we are putting on. Like this. We actually don't need that much. Just cut the excess. Like this. And then we shrink it, and I think we are putting it on our arm. Nice. Also, what I like to do is take a picture of the receiver, so just in case I forget what I soldered, I can later check it again. Like this. Okay. What's the camera saying? We are at 50 minutes. It's adding up, but I think we are still on a good pace. So where do we put this actually? I think we go like this. And the antenna goes over here on the arm. Right. That looks pretty good, I think. So how are we doing this? I think we need some double-sided tape to fix it in place, and then we maybe wrap it again with some of the other tape. I could put it under the cables. I don't care. We use the double-sided tape. That's the stuff. It's already glued to the... Okay. Like this. That's already too much. Let's cut some off. Yes. Okay, this go here. Antenna goes here. Like this. Let's just fix the antenna in place already. And I will wrap this one with some tape as well. Okay, let's keep going. The DJI Nano can record for about 1 hour, and so we had to do a little break. I went ahead and printed out some TPU spacers for the VTX, because the VTX is sitting fairly close to the USB port, which is not perfect. I will also put a little piece of tape over here. Let's do that right now, because I don't want anything to happen if it ever comes to touch the USB port. Just like this. That should prevent any touching. Okay, so let's actually solder, or maybe let's tin the pads for the receiver. Yeah, let's do the receiver first. So we do put the receiver here on the R2 pads. And we just shorten them close to the pads actually. Not too short, hopefully. Okay. That's good. And the green one. And we're removing the insulation from the cables. Okay. So we put a little bit of flux on it. Cable as well. So now we tin the pads. Let's see. Come on. My ground pad is always the worst one. Nice. The last one. I need a little bit more flux on this one. Oh, that is looking good. little bit of tin on the cables now. Nice. Okay, so you can do ground and 5-volt first, and then I have to check on the picture I took earlier on the receiver to see which one is the T and which one is the R cable. Okay. Okay, let me check the picture I took earlier. So the green cable is T on the receiver, so that one goes to R on the FC and vice versa. So the white one is next. Let's do this. And lastly the green one. Love it. Great. And now we do the VTX on UART4. That is, I think. Yeah, that's UART4. Let's put a little bit of flux and tin the pads, and then we check the lengths for the cables. I think we can maybe cut a little bit. I like to do the cables as short as possible. Okay. Clean tip. And let's tin this up. A bit of solder on the tip to spread the heat and go. Yeah, those ground pads can be a pain in the butt. Okay, nice. Yeah, that looks good. And now let's see how we do the VTX. So this is the front, like this. So we do the camera in front and we do... It looks good. Now we use our spacers because I want a little bit more space between the VTX and the AiO. I have these on MakerBot, by the way, so if you need some of the like little TPU washers, you can print them yourself. Fairly easy design. Okay. It looks good. Let's see if it is enough. Now we got the space we need. Okay, so the pads are over here. How do we do this the most efficient way? We can turn it like this. And then we can cut a little bit more of the cable. And also we can route the UFL a little bit differently. Fairly stiff cable. Do it like this. It looks good. The camera should be sitting here. That looks good. And then we have a very short path for the cables. Right. Can shorten them a little bit, but I kinda want to go like this and be able to fold it over like this, so the cables can't be super short. Okay. I can shorten them a little bit. Like this is fine. You always want them as short as possible, right? So let's remove the insulation a little bit. Not even sure if you call it insulation in English. Maybe we call it isolation. You can tell me in the comments if I'm saying it wrong. Okay, let's tin the cable real quick. Bit of flux, as always. Nice. Okay. I don't think the third coffee helped with the fingers. Okay, so now we want to solder this. Maybe let's take another picture of the VTX. Double check the wiring diagram. So it's ground 5 volt R and T. So we start with the black cable, which is our ground. I think I want to go like this actually. Pliers. Tweezers actually. Nice. Okay, and now we have R and T. 3 cables R, so we do the yellow. Same as with the receiver. R goes to T and T goes to R. We would still get a video if we do it wrong, but we don't get OSD because the communication between the VTX and the FC wouldn't be there. Last cable. And we are done. Nice. Okay, so now we just do it like this. Maybe we do a little twisty twist. Perhaps with the cable management. And we put it on. Come on. Nice. Actually, let's put the camera in the mount. It doesn't matter which way you do it because you can always... Oh, there's still support in there. Let's remove that. Might be a problem. Okay, so now camera into the mount. Goes in like this. Nice. That's looking good. Perfect. And now we do the... Oh, there's also a support in there. Let's remove that. We had a little bit of stringing, but so I can take care of this. Just like that. Perfect. Now we put the SMA connector in there. Yep. Nice. I think I got some screws for that as well. I can turn off the soldering iron. Where did I put those? These here. Little short ones. Oh, they are actually Torx. Almost. That's the right one. Don't throw it onto the table, the dog will think it's food. He's like a little crocodile when it comes to food. Okay. Now we put antenna here. Cable routing. Looking good. Actually, make sure not to get the battery lead between them. Nice, okay. It's starting to look like a drone actually. Okay, now we put on the little stop nuts here. Have the little nylon ring. And I have to shorten the stack screws as well to get the top plate on. But if you do that, you need to put on the nuts first, because if something goes wrong, you will have a problem to screw the nuts on. Like, I'm going to like snip the top of the screw, and sometimes that deforms the screw, and then you can't put on the nut anymore. And we don't want that, so the screw was on before. This one's tight. It might look stupid, but it works. And we only have 6 hours to build this, so we have to go fast. But I think we are still well within the time. We are at 1 hour and 20. The dog is actually sleeping, so we have some peace here. Okay. I need to still go a little bit further. You might look away for a second. Usually you would use screws that are not this long, but I didn't have any other. So these are like 40mm screws or something. And now I just cut them here. Don't do this at home. Also don't use your cable pliers for this. I did this before, they bend and they break. And the last one. Very close to the standoff here, which is kind of hard to do. Okay. Let's screw down the nuts a little bit more, and maybe I have to cut the front one even more. And there is space, okay. But I have to cut the front one again. Damn it. Actually, I have to remove the camera for that, because the standoffs are in the way. Oh, the back one is also too long still. So let's go right over the nut. Nice. This is so fun. Okay. I woke the dog up. Great. Snippity snip. Not sure if we can have to cut this one as well. I think we have to. Damn it. Yeah, let's screw on the front again, and then we do the same with the back side, because I can't get to it properly. Oh, that's the wrong. That's the wrong screw up. Damn it. I was wondering how did I do this before? So, big tip, get stack screws that are the right length. You don't have to cut them. Alright. So now let's do the back screw. Yeah, it's still too long, damn it. Yeah, next time we get proper stack screws and we don't have to do this. But there is always a thing like that, right? You always have a little hiccup during a build. So let's cut the last screw and try not to damage anything doing it. Ka-ching! Okay. Also, I'm using fairly long screws actually, because I feel like it makes the quad more stable if you do that. Like the aluminum standoffs are kind of bendy, right? And if you use longer screws, they make the standoff less bendy basically, because we have like, they act like a steel core for the standoff. Just don't use too long screws, because then you can't screw on something from the top. Make sure that the cable is not pinched. Okay, nice. That's looking good. Okay. We need this screw, and then I think we can do our first plug-in. But I need a VTX antenna before I do that. I always have to put a VTX antenna on before putting power on it. Okay. Pinching the cables. Nice. Okay, let me grab an antenna. So, if you don't put a VTX antenna on, you might fry your VTX. It always needs an antenna. Okay, time for the first plug-in. I got a short saver. We put that in, and then we put the LiPo in. And if we did everything right, it should turn on. This is looking good. This is sounding good. And we didn't get smoke. Nice. So that worked. And now we put it in without the smoke stopper and hope that it still works. Let's go. And we still don't get smoke. Very nice. Okay. I hope this one is short enough. Let's see if we can fit the top plate. Barely, actually barely. Screw is still too long. Is it? We have to cut this one again. Let's see if we turn it. Like this. This should work. No. Very nice. I also got a Dremel tool now. I don't want it to be too tight here. Let's screw that back out a little bit. Because we still have like zero space to the other side of the... Yeah, now we have some clearance. Okay, now the top plate should fit. Nice, okay, that works. Let's tighten up the nut on the stick screw real quick. Okay, so time to put on the top plate, and then we can go over to the PC and do the Betaflight Magic. Maybe I record that as well, but that will be just PC because I don't have a good option to record myself doing the setup. Okay. And let's go over to the PC and do the rest of the setup. Let me put in some screws into the top plate. What do we have for this? This should work. Okay, those are tight. Now we can tighten these. And that's it basically. I have to still put on a elbow pad because I'm not using the cage today. Also the strap is a little bit long, but it's on. Or maybe I cut it off a little bit. So that's the Ballerina for you. Took us 1 hour and 40 minutes. And now I do some Betaflight Magic and then we do a test hover and maybe fly it. Maybe. Okay. Now we will flash the ESC. Let's see if it works this time. Put in read settings. Flash all, Blue Jay, newest version, 24 kHz PWM frequency. And we hit flash and it still says it can't find flash data. I think we stop trying that one and we do the Betaflight setup first. And I have to look into why that's not working.
We did it. We have to flash to 0.18 because later firmware versions are not available for the ESC.
So we connect Betaflight. First thing we do is calibrating the... actually, let me put this in English so you can understand it. We connect. First thing is calibrating the accelerometer. Like this. Now we check the... Let's reset the yaw axis. It's moving correctly. Like you see, I'm moving the quad and the quad in Betaflight is moving the same way. That means that the gyro is orientated correctly. Okay, now they put the VTX on UART 4. There's our display port, okay, and the receiver is on UART 2. Save and reboot. When I go over to my saved settings, I'm just, you can see this here, this is like the standard settings I use on all my quads for Betaflight, so I don't have to do everything. And I just throw this into the CLI. Into this one. Enter. Let's see if you have... we have to... Let's just do the VTX settings. Wait a quick. Yeah, since I'm using HD0, I can just load the HD0 preset. If it doesn't show up, you have to select all firmwares here. So we have HD0 VTX. I'm checking the firmware here. Okay. It's like all, and it is on UART 4. Pick. Agree. Save and reboot. So I'm just going through and checking, so the CLI didn't work. That's sad. I might have to do this the hard way then. Maybe we didn't save it. Okay. Connect. So now we check the, yeah, that worked. This is correct. This is fine. So I'm now just go through and, oh yeah, you can also load the preset for the package rate for ELIs. Save and reboot. Pit tuning. I will disable the low pass filter one. The rest will stay for now because I have to figure out why the ESC doesn't flash. Okay, we put it to D-Shot 300 and we can't enable bidirectional D-Shot yet because of the ESC problem. Okay, so let's check the motor directions. Motor direction reversed is already set up. Put in the LiPo. And now I just, first I do the reorder thing. And I click the moving motor. Okay, save. Motor direction. And my cable is a little bit bad. Okay, I understand the risk. Don't do this with props on, because you will have a bad thing happen to you if you do that. So, and now I just check if the motors are turning the right way. So this one is correct, this one is wrong. It's number 3. Number 4 is false as well. Okay, everything is moving nicely. So that's done. Let's check up on the OSD. That is looking great. Video transmitter is looking good as well. Let's set up a black box. Logging is on. Let's just select the debug mode that will benefit us. think we do the frequency thing. I can unplug the LiPo actually, so that the thing doesn't heat up. I think that's something like FFT frequency we use. Nice, okay. Save and reboot. And I think... Oh, we have to flash the ELRS actually. Let's do that as well. So we start up the ELRS configurator. I have to let's just do the setup first. It's a radio master. RP1. We use Betaflight pass-through. We are in the EU. We have bind phrase selected. And now I just unplug it. Unplug it. And plug it back in. Now we select the port and press flash. And that should work. Yeah, it's working. Pretty easy actually, if you do it right. Let me grab the radio to check up on the switches. Okay, let's unplug it. This is a super fat cable actually. Come on. Get out of there. Nice, okay. Plug it back in. We are already getting telemetry. So now we go to the modes tab. And we have working switches. Okay, nice. So it's time for putting on the props and do a little test hover. So this will be the first test hover. Let's see if it flips out. Flying. Nice. Maybe I should screw on the props. We lost 2 props doing this. That was pretty stupid. Okay, but it is flying. Let's go.